Aloha and welcome to this experience. We're going to do a practice WOD for Project Euler Problem 2. Just like the last one, this is to help you get used to Intellij and Github and Java and doing practice WODs. Probably want to have done the first one before you try this second one, and certainly I have. And the idea for this one is we're going to solve problem 2 from Project Euler, so let's take a look at that. And the idea here is that we have the Fibonacci sequence, where each term is the sum of the last two. And what we're trying to do is figuring out for all those in the Fibonacci sequence below the value of 4 million, sum up the even valued terms. So this is just a little minor tweak on the last one. So let's get started. We'll go to time. We'll start timing. We have to create an empty GitHub repo called Project Euler 2. So we'll go here. We'll type in Project Euler 2. And we'll have a Java gitignore and a new GPL. We'll create the repo. There it is. We'll do a clone in desktop because obviously the next one's going to be saying to download it. We're going to download it into this directory. So we'll do clone. There she is. So we'll hide this. And then I believe we've got to create an Intellij project. So we'll bring up Intellij. Again, this should load within 5-10 seconds. And once it's there, we've got to create a new project. And it's going to be a Java project 1.8. Go to next. No template. And then we want to say it's in the project hosting 613 Project Euler 2 directory. So I'm going to choose that. And we're going to do finish. And within a couple seconds, we'll have the thing up. So let's go back and see what we do next. We want a main method that computes the answer and prints it out to the console. Okay, so to do that we go in here, press the source, type Control-N for a new Java class, and it's going to call it Project Euler 2. Type return, sure, add to Git, and then press get inside Project Euler 2. Project static void main gives us our main method, and we're finally all ready to start doing our programming. So let's remind ourselves of what we're going to do. We're doing this Fibonacci sequence. So we're going to have the first two terms, 1 and 2, and then go through it. So one way to do this, let's have an int called head term, which is equal to 2, and an int tail term, which is equal to 1. And then we'll say while head term is less than 4 million, right? 4,000,000. We want to do something, right? Well, we want to check. Oh, and then we need a sum because we're summing things up. We initialize it to 0. So while the head term is less than 4 million, we want to say if head term divided by 2 equals 0, or I should say it's not divided by 2, but the remainder after being divided by 2 equals 0, then we want to increment sum by head term. And then we want to get a new head term, which is going to be equal to head term plus tail term. And then we're going to say head term or tail term is going to be equal to head term, and head term is going to be equal to new head term, and then we're going to go back through the loop. And then at the end of that, we are going to have to print out, print line, whatever it is, sum. Okay, so that seems like it should work. Let's just run it just for fun, see what the heck happens. We run, okay, and then, so we get this number. Of course, you know, who knows whether that number is the right one, so it would be nice to have some kind of test to check to make sure, but in the interim, let's try something different, which is, just gonna check to make, yeah, we've got, I was worried that my timer wasn't running, but it's running. So why don't we, instead of doing tests, why do tests when you can do print lines, or print f's, we'll say, what are we going to say? We'll say head term equals %d, tail term equals %d, and sum equals %d. And then we got to put in a new line. And I'm going to show you something else here. Let's make this about like 9 wide. This is the padding number. And that way it will, you know, things will kind of space them out or appear nicely in columns. So now let's run this one. Okay. Oh, doggone it. Oh, I forgot to, forgot to add in the actual head term, tail term, and sum. Okay. Let's try to run this one. Okay, if we look at this, we see 3 and 2, 5 and 3, 8 and 5. So 3, 5, 8, 13, 21, 34. The first thing to check is just make sure we've got the Fibonacci sequence correct. And then we see that, you know, we've got the same Fibonacci sequence, kind of just one behind, which is what we want. And then the sum is 2. And then we add 8 because that's the next even one, so we get 10. And then the next even one is 34, so we get 44. So it looks like our sum is increasing. But the question is whether or not we're stopping at the correct point in time. And what you can see here, which is a little disturbing, is the fact that our head term, when we print out the last time, is over 5 million, and it's supposed to be only over 4 million. Okay, so let's think about that for a second, and if you think about it for a second, what you can realize is, well, maybe we're printing this out at the wrong point in time. We're printing it out after we've done the increment of head term, but before we've tested to see whether we want to exit the loop or not. So the easiest way to probably fix that is to move that line up. And to move the line up, we're going to use Command-Shift-Up arrow. So bing, 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 that moves that up. So let's run it again. Okay. And now this is a better, you know, kind of explanation of what's actually happening, and we can see that the last head term that's actually been used to potentially increment the sum is at 35, 2, 4, 4, 5, 7, 8. So it looks like we got a good answer. I'll comment this out, and then if we go back to our problem specification, we informally tested, we've got to commit the finished program to GitHub. Let's go back here, so finished WAD 2, commit and sync. Okay, so it's all done there, and then we can view on GitHub by doing this, and we can see it's there. And just to kind of show you another thing, what you can do is you can see that the initial commit, if you move the mouse over authored 8 minutes ago, it shows you the exact timestamp of the initial commit, 11:43, 11:52, So you know, it shows that it's about 9 minutes long, and in fact that's what our timer says. So we're going to call this a 9-minute WOD, and there you go, WOD number 2 in the books.